the Purdue Peak golfer. I'm Sammy.
I'm Micah.
And I'm Alex.
So, some background information. Our primary inspiration were obviously two Purdue icons, Purdue Pete and then our glorious bell tower. We also incorporated a windmill that you would normally see on a miniature golf course. So we combined the windmill with our bell tower to create a golf obstacle for our Purdue Pete golfer here. So some previous toys that we looked at were primarily the chip shots golfer. So this is a type of toy that would sit on your desk. It has a spring-powered golfer and then a magnetic ball and putting green so that you hit it using the golfer and it lands on the other golfing green. We liked the idea that the two pieces could be put wherever you wanted with things in between them or not, and adjust your level of difficulty like that. So that was our primary inspiration. There are also a variety of other desktop golf toys that we looked at for different mechanisms and options for the golf swing mechanism itself. So our target audience is primarily people affiliated with Purdue University. If you're a fan of the university, you'll be more inclined to enjoy our figures here. We recommend at ages 10 plus. It does require significant two-handed dexterity to use our golfer, and then the small ball also presents a choking hazard, so we don't encourage it for younger age groups. For our concept generation, we are pretty true to our original concepts in our model here. We have the Hammer Golf Club. On this side, you can see some of our original ideas. We thought that we could do a Purdue strength test, so this was a different type of hammer mechanism, but in the end, we still have the type of mechanism down here that we use today. In the bell tower, again, from the beginning, we have the electrical systems, the sensor mechanism we wanted to use, and then our first stage sort of ideas of what our bell tower would look like. We've changed some sizing and some features, but all in all, it's about the same. So how to play? The objective is to use our little putter here to cut a ball through the archway at the bottom of the bell tower. The windmill blades do spin, and that's the extra challenge, is you have to get the ball through the archway of the bell tower while the windmill blade is spinning. So Hail Purdue plays when the score is detected. If you get the ball through, you get a reward of a song. So some basic strategy, we have if you want to turn it, we have a grip on the back here, this Purdue P. The best way to do it is to hold this. You can pull the arms back, and then the mechanism is released when you lift the head. So that'll cause his hammer to swing and strike the ball towards the bell tower. So you can adjust the difficulty if you want to play this with other objects. We envisioned this as a desk toy, so you can take your stapler and your tape dispenser and other objects and put them between your golf figure and your bell tower figure if you want to shoot it over things or through things or around things.
So our modeling software that we used was obviously Creo by PTC. On the next slide here, you can see some of our final models we made. There's the modeled assembly for the Purdue Peak figure on the left and the bell tower on the right. So a little bit about the Purdue Peak golf figure. This is a cutaway view of the internals of it. He's made with certain press fits and then glued together. You can see our ratchet and pawl mechanism on the inside. So there's the ratchet in brown there, and then the pawl is the gray piece that connects to his head. With the ratchet and pawl, you're able to get a variable swing, so you can cock his arms back to different configurations, I guess. So you can get different power and different velocity on your swing. It's user-initiated release. To release the swing, you just lift the head up. It's going to release your ratchet and he'll swing forward. And all of that is powered by a spring on the inside here. Next we'll move on to the bell tower. So this is a pretty complex part. So we have these 3D printed top and bottom pieces and then laser cut sides. On the inside we have our motor shown here in gray. We have our motor driver in red, and the battery, the circuit, and the Arduino are on that top shelf in there. And this has our score detection system as well built in. On the next slide here, you'll see a bit about the electronic circuit on the inside. So what we have is a 9-volt battery that's controlling both the Arduino, and is powering both the Arduino and the motor driver. The Arduino is sending signals to your 16 RPM geared DC motor, and that's controlling it through the motor driver then. As well, we have our score detection system. So the score detection system is actually built into the base here. You can see we have a set of 3 photoresistors on one side and then 3 lasers on the other side. So the lasers are going to shine onto the photoresistors and send readings from the photoresistors to the Arduino. And And once the reading drops below a certain threshold, such as when the ball passes through and the laser is blocked from one of the photoresistors, that's going to trigger our score detection circuit, which will play Hail Purdue through the piezo buzzer located up top here. It's that black piece in there, so we'll see that. So these are just little exploded views of our assemblies. You can see everything came together in both the bell tower and Purdue Pete figure. Next video is going to be a quick animation showing you the different sides of Purdue Pete as well as his swing. So right here you can see the user is going to pull his head up, lift it back, press it into place to lock it, and then lift it and he'll swing forward. And now you can see the internals of that with our ratchet and pawl mechanism. And then there's a similar video for the bell tower showing you different angles of it as well as how it spins. And then finally, we're going to have an animation of Purdue Pete actually golfing through the bell tower. You can see him there, he's released, hits the ball, and it'll go through the bell tower there, hopefully triggering your score detection system.
Yeah, so I'm going to talk a little bit about prototyping our final product. So mainly we did a lot of 3D printing. The Purdue Pete is entirely out of the SLA print that we did. And then the top and bottom of the bell tower are both 3D printed, uses the Lowell's TASs provided by ME. So you can see all of the layout of our pieces. And then this is the partial assembly of the inside of Pete. So it's showing the spring that's attached to the back face of his torso and then connected to the front arm piece. So on the next slide, we have all of our laser cut pieces for the bell tower and also Purdue Pete's base. So we spray painted all of these, and it also shows our initial prototyping of the sensors and trying to get those to line up within the bell tower assembly. So these are our physical prototypes. As you can see, in addition to spray painting, we did some detailing on his face, hands, and then he has a little jersey on the back. So that's that. Yes, we have a video of us trying to shoot it through. As you can see, I was blocked by the windmill mechanism, but now we can go ahead and show you our physical prototype. So I'm going to go ahead and lift up his head, and you can rotate the arms back in order to initiate the swing. To press his head down, it kind of sets the swing, and set up your ball. So there's the block key on the back is actually the handle, so you don't get in the way of his swing. So if you line it up, we'll see if we can score. Hey!
And one of the issues we did have is if it goes through too fast, it won't trigger it, but that's the sound it will make if it does end up triggering the sensor.
Yeah, so a couple improvements we wanted to note on for our toy. The main thing we wanted to do in order to produce it for the public was mainly to enclose all of the wiring. So have an external battery pack and on-off switch. That way all of the wires are hidden from kids. And a couple other things we want to improve on given a larger budget or more prototyping time. So with that, we're open to any questions.
So in the slide where you had the electronics, the gum packet, was that just to help show something, or is that actually inside the
Yeah,
bell
if you go
tower?
back to that, Samuel. So you have to have the photoresistors are on that breadboard on the left, and I
Yeah.
needed the lasers to line up with it without me holding them. So the pack of gum is about the same thickness as the breadboard, so they're just mounted on top of that.
Nice. Okay.
Did you have any problems with the Purdue Pete because it was just so small, or did you feel like
The main problem we had was that we had initially created a seal on the inside to keep the arms from popping out of the chest cavity, but that was too tight fit in order to let it swing freely. So by getting rid of that piece, you can still pull his arms out, but it's so press fit in there that it's really hard to do.
Any other questions?
What was the most difficult thing about designing the bell tower part?
Definitely the 3D printing. We had initially planned on both of these two prints being one piece, and that wasn't possible because it was like a 5 and an 8 hour print. So by splitting it up into the different pieces and splitting the arches in half, we were able to do a lot smaller prints.
The wiring is also very difficult since you have a wire channel in each of these front pegs here running up. It has to have 3 wires, one for each of the lasers and the photoresistors, and then getting that all to wire up with the motor driver, Arduino, and everything inside this fairly small space is pretty difficult.
Yeah, how would you solve the problem of detecting the
So I think part of of it is the fact that with this small of a distance, it's pretty fast. So either we would use a marble, which would have a slower velocity when it's hit with the same speed for peat, or having different obstacles so it goes through slower.
Yeah, or different sensors. We could also try some IR sensors, see if those would work better. It was also difficult getting all the lasers to line up on each of the photoresistors, because some of them would be askew, and it's over a decently large distance that if they're askew by a little in the mount, it would be hard to line up. So just get that to line up a little better.
Can you like start from like smaller angle to
Yeah.
Yeah,
maybe
so
it will get
the
slower.
gear inside, we can go from like that small of an angle
Yeah.
and hit it pretty slowly. But it goes up to about halfway is about as far as the gearing goes from the inside.
So the hammer is made of the same material, or the hammer is actually made of metal material?
It's 3D printed.
Yeah, it's all from the SLA 3D printer.
It's all one